Welcome to the Islesboro Forum. It's the second of our 2023 speaker series, and we will be recording tonight, so the program will be available on YouTube in a little over a week. Last week's program is being posted within the next couple of days, so watch for it if you are interested in doing so. Our format tonight will be one of receiving remarks from our speaker, and then we'll open it up for question and answers towards the end in the last 15 or 20 minutes. We are very grateful to Forum Committee member Peter Rothschild for bringing our speaker to us tonight, and therefore I will turn it over to Peter to do the detailed introduction of the speaker. Peter.
Thank you, Gail. Thinking about climate change, I'll have to admit that over the last few weeks, I felt a certain smugness that I never wished to live in either Florida, Texas, or Arizona anyway. But David Reidmiller will no doubt tell us why we have plenty to worry about here in Maine. As director of the Climate Center of the Gulf of Maine Research Institute, David offers an unusually broad, comprehensive insight into what lies ahead and what we can do about it. Among his impressive accomplishments, David served as chief climate scientist for the U.S. Department of State and lead U.S. science and technology negotiator for the Paris Agreement. Please join me in welcoming Dr. David Reidmiller.
Well, thank you, Peter. I kind of want you to come along everywhere I go so you can introduce me even at home sometimes. But really, thank you all for joining this evening, and a huge thanks to Peter for the invitation and to all of you for hosting us here. I have about 35 or so slides, and we're going to get through them. And feel free, we can keep this as informal as you want. Feel free to ask questions throughout. I can still see hands, so I want this to be kind of as engaging and hopefully not sleep-inducing. We'll try to keep the science not to a minimum, because at the end of the day, I'm a scientist, and it's really important to understand the science, but want to present it in an accessible way. And before I get started, I just want to say a quick note about the Gulf of Maine Research Institute. Just a quick hand, how many have heard of the Gulf of Maine Research Institute? All right, that's pretty good. All right, good. So GMRI is kind of a small, mid-sized nonprofit based in Portland. I'll talk a little bit about it at the end of the talk because we really start to address what we're doing to think about climate change. We've been on the waterfront of Portland since about 2005. We have a beautiful facility. If you're ever down there, feel free to contact myself or Maggie, who's here, and we're happy to give you a tour anytime, tell you a little bit more about what we do, why we do it, how we do it. But really what we're in the business of doing is developing collaborative solutions to global ocean challenges. And we do that through kind of a basic research team, your typical scientists. We have community engagement experts. We have also a really strong education component that focuses on keeping middle schoolers engaged in the STEM fields, because that tends to be the age at which they start to get discouraged with science, technology, engineering, and math. And we want to make sure that people can see themselves as scientists to address issues like climate change for generations to come. So with that, let's get into the meat of the talk. And I'm going to start with just an overview of the variety of climate risks that we face in the Gulf of Maine. And you can kind of look at these different rows. You have kind of physical impacts of climate change, chemical impacts from climate change, and then biological and ecological impacts of climate change. Rest assured, I'm not going to talk about all these tonight in detail, but I am going to talk about a couple of them. And in particular, we're going to talk about warming waters. Many of you have probably heard the talking point that the Gulf of Maine is warming faster than the vast majority of the world's oceans, more than 95% of the world's area. And we're going to talk about sea level rise, and we'll talk a little bit about species shifts and things of that sort. So If you have questions about the other ones, we can certainly get into them, but that's not what the bulk of the talk's going to be about. So let's talk about ocean warming. We look at satellite data collected from NOAA, the National Oceanic and Atmospheric Administration, to understand how the Gulf of Maine is behaving both on a seasonal and an annual time scale. And what this plot is showing, the black line shows the annual average sea surface temperature anomaly. That's basically the deviation from the long-term average. And that's a standard kind of measure in climate science to understand how the system is behaving. And so you can see any given year, it's really noisy. There's a lot of up and down driven by what we call interannual variability, things like El Nino. And you can also see that the past 10 or 12 years have been pretty warm, right? Pretty warm, about 3, almost 4 degrees Fahrenheit above the long-term average. And the box that's highlighted in red really shows where we started to see this bit of a regime shift in the Gulf of Maine. And we'll talk about what that has looked like and what the consequences are. But it really led to some rapid warming and some sustained warming that we're now seeing. But that is superimposed on this long-term warming trend, which is what you see in that blue line. That's basically the trend line for that whole data series. And superimposed on that is that green line, which is the warming trend for the world's oceans. And so what you can see then is that the Gulf of Maine is warming about 3.5 times faster than the global average. And part of the reason why that's so important is because that has real ramifications on how the system responds. The rate of change really dictates how species, fish, other types of things behave. And so we can take that apart even further. I won't spend a ton of time on this plot, but this is basically that same type of annual average, but broken down by season. And so you have the spring, summer, fall, and winter. And again, you see variability across the seasons, but the overarching trend is the same. We have a long-term warming trend with a punctuated regime shift somewhere around 2010, basically. And in every season, we see warming in the Gulf of Maine that is significantly higher than that of the global average. And it's the fastest in fall, where it's 4.5 times the global average, which is remarkable. It's warming at, it may not seem like a lot when something's warming by only a degree or so Fahrenheit per decade, but when you keep adding those decades together, that really means something. And you can think about, the analogy I like to draw is the Earth system is a lot like the human body, We are acclimated to having a system that operates at a very narrow temperature window. And so when we run a fever of just a couple of degrees, you start to get tired, feeling icky, right? Once you get, a temperature of 101, 102, 103, you're going to probably need to get to the hospital soon because your systems are going to start to shut down. And that's exactly the type of stuff that's starting to happen in our environment here in the Gulf of Maine. Another way to look at this is by looking at the extremes in those annual averages. And so what this plot shows, it's complicated, but it's really kind of an interesting plot. It's what we call a heat map. And it shows daily sea surface temperature anomalies, so that same data we were showing before, but for every day going back to early 1982 when reliable satellite data came into being. And so you can look at January 1st, 1982 to December 31st, 1982, and then you go up each year. And so obviously as you move further up the plot, you see warmer and warmer temperatures indicated by those red colors. And the other thing we see is that those reds not only tend to become more prevalent, but they become deeper red, meaning that those anomalies are getting more and more intense. And then you see those black lines superimposed in them. And those black lines denote when we've crossed the threshold into a marine heat wave. And you're probably familiar with heat waves on land. It's the same thing in the ocean. And we define it by having 5 or more days where the temperature is higher than the 90th percentile of the long-term average. And that's a lot of stats for those that haven't practiced in a while, but basically it's really that really upper limit of what the heat is. And you can see that 2012 year was when we really started to have some significant impacts on the lobster industry. Helpfully, the whole supply chain adapted and has been able to absorb when that does happen again, because it happened in 2016. And you can see, especially the past 2.5 years, have been almost a near consistent heat wave. So what does this look like spatially? So the dotted line there denotes what we call the Gulf of Maine for the analysis that we show. And you can see the bathymetry of the Gulf of Maine superimposed on that, which is probably familiar to a lot of folks in the room. We have that large feature, Georges Bank, right, that extends off of Cape Cod. And that really kind of cuts off most of the Gulf of Maine from the broader North Atlantic ocean system. And we have, as you'll see in the next slide, some big ocean currents at play once you get off of Georges Bank. But the Gulf of Maine itself is a pretty kind of contained system. And so it can take a lot to change systems once it's kind of reached kind of that tipping point like we've seen in 2010. And the other important thing to note is that while it's warming a lot here in the Gulf of Maine, you can see that sea surface temperature anomaly just off the area where we focus our study is actually warming quite rapidly. This is just an average annual anomaly for last year, but you can see just how warm last year was in that North Atlantic region. So why is this happening? I mentioned that this region is influenced by two major ocean currents. The first is the Labrador Current, which, as you know, comes down from the north, from the polar regions, typically bringing colder water from the Arctic. But we know that Labrador Current is warming, right? The Arctic is probably the fastest warming place on Earth. And with that, we are getting warmer water in that Labrador Current that influences this region. In addition, we are influenced by the Gulf Stream. The Gulf Stream is that massive current that starts down in the tropics, brings enormous amounts of heat energy from the tropics into the mid-latitudes and extending across the North Atlantic. And it's why, say, England and Wales and Scotland and Ireland are much more temperate than those same latitudes over in Canada. It's because the heat being brought over there by that Gulf Stream. But what's happening is that Gulf Stream, instead of being a concentrated stream of warm water, I like to think of it as like the jet setting on your hose, like it had been for a long, long time. It's almost like we're turning that dial into more of a shower setting. So it's widening that span. And so we're seeing a widening of the Gulf Stream. And that means that we're getting more water and more warm water from the Gulf Stream entering into the Gulf of Maine, a system that had historically been dominated by the Labrador Current. So we have really kind of multiple things at play. We have a Labrador Current that is warming, and we have a Gulf Stream that is changing and having more of an influence in this region. So, okay, it's warming a lot here. Why do we care? Well, a big part of the reason why we care is because so much of the livelihoods and well-being of coastal communities throughout the Gulf of Maine depend on the marine resources that we can harvest commercially or in a farm setting from the Gulf of Maine. And we know that decreases in both cod and lobster productivity have been linked to increases in temperature. In addition, we can see that the hospitability of this region to various species is changing. And these plots basically show the center of biomass, so where is the majority of that species located by latitude. And so you can see basically that the American lobster, right, we're probably at about 43.5, 44 degrees north latitude. So we're right now kind of at peak lobster. We're in pretty good shape here. But if you go down to Connecticut, for a variety of reasons, in Long Island Sound, there's not much of a lobster fishery to be had anymore. In contrast, if you look at black sea bass, we're seeing an explosion in black sea bass concentration in this region. And that opens up a lot of opportunities that we'll talk about in a second. But the other reason why this matters is because it's not just what's available out there, it's the whole supply chain that's dependent on them. It's the dockside dealers and processors, it's the retailers, it's the all the service industry that depends, and then frankly the tourism and recreation industry that relies on it as well. So you see not only fluctuations in supply because of this warming trend, you have these heat waves that can be somewhat of a surprise and therefore kind of cause disruptions. And in the process, businesses are having to incur additional costs, whether it's because they need to develop more production capacity throughout the year, or because they need to buy up more insurance to insulate themselves from the risk of volatility or changes that they have not yet really embedded into their operations on an annual basis. But I mentioned that there's opportunity in this as well, and I want to make this clear that we focus a lot on the risks of climate change, and sometimes there are opportunities, and we need to be forthcoming about them. Globally, of course, the risks far outweigh the opportunities, but it is important to recognize that there are some, and we ought to be capitalizing upon them because there are going to be risks that need to be offset. And one of them, like I mentioned, is the arrival of black sea bass. And what this plot is showing is basically the annual catch limit, basically what's allowed by law to be harvested for every state from Maine to North Carolina. And historically, black sea bass has primarily been kind of a mid-Atlantic species. So understandably, the regulatory regime has allotted the quota and permits to fishermen in the mid-Atlantic. But you can see up in Maine and New Hampshire, we have virtually no ability to harvest what we're already starting to find out there. And so we're working to sort of create a more dynamic permitting regime that would enable fishermen here to sort of capitalize on this new economic opportunity. Similarly, if we look at the aquaculture industry in the region, there's a number of things that can be done to sort of insulate themselves from a variety of risks. I highlight not just what's going on with warming, but also ocean acidification and heavy rainfall events. Those heavy rainfall events can cause a lot of pollution and nutrients to run off into the coastal zone, and that can trigger harmful algal blooms or other types of toxic events that can really cause significant damage to an aquaculture facility. And so Mook Sea Farm has been one of the industry leaders, not just regionally, but nationally, in how to insulate themselves from the risks that these climate impacts pose. And that includes having shoreside infrastructure, such as hatcheries or other types of reserves, to basically insulate themselves against the risk. So, okay, talked about warming, let's talk about sea level rise. And it's important to note that sea level rise is caused not just from the melting ice caps, whether that be Greenland and Antarctica or the glaciers in Canada, but it's also caused by the thermal expansion of water, right? When you heat water up, it expands in volume, and that's a pretty significant impact not to, that's right, exactly. And so these two plots show the observed sea level. I think this is from the Portland tide gauge, going back on the left here to the early 20th century up to basically present day. And you can see that it's more or less risen by about an inch per decade over that time. So since the beginning of the 20th century, sea level, particularly in Casco Bay, but throughout I think it's safe to say throughout the Gulf of Maine, has increased by about 9 inches. And what you see on the right-hand plot there is a similar thing. That blue squiggly line is sort of the historical observation, and then those dotted lines are different scenarios of sea level rise going out in the future. And what those are dependent on is the level of warming that we ultimately witness in the world. And that level of warming is really dependent on what we as a global society do with greenhouse gas emissions. If we're able to collectively come together and reduce our emissions, we're going to be much more closer to that blue curve. But if we continue on a path where major emerging economies around the world continue to develop their economies based on coal, if we in the developed world fail to decarbonize quickly enough, we can very likely be on a path much more close to that black dotted line that shows us up to about 9 feet of sea level rise by the end of the century. Now, for that to happen, we need a lot of bad things to occur, and that includes tipping points in some of the ice sheets in Antarctica and elsewhere, and those are still really unknown. But from a risk management standpoint, you want to keep those things in mind. And that's why the state has really been especially under Governor Mills' leadership, taken on climate change as an issue and really embedded it in the policymaking apparatus. And what you can see is that we have the Maine Climate Council, which was stood up early on in her first term. That Maine Climate Council and its scientific and technical subcommittee leaned into this federal interagency report that characterized sea level rise over the next century throughout the country, brought that into sort of a policy framework called Maine Won't Wait, which many of you may have heard of. And that's really sort of laying out the plan or the strategy for the state at all across the state, every economic sector, every county, thinking about, okay, what can we do to address climate change? And when it comes to sea level rise, they came up with two different scenarios to follow. One is a commit to manage scenario, which is sort of this sort of intermediate scenario of having 1.5 feet of sea level rise by mid-century and 4 feet of sea level rise by the end of century. There's also a prepare to manage scenario, which is more like that black dotted line that I mentioned that basically has 4 feet by mid-century and 9 feet by the end of the century. But the legislature a couple years ago passed a law mandating that state agencies were to reassess their regulatory frameworks and their regulations and policies and guidance to integrate this commit to management and this commit to manage scenario. And so what we're going to show here is basically what does this commit to manage scenario look like in Portland? And we'll shift a little more close to home a little bit in a second here. But in the top left, what you have are basically what we call a probability distribution function. So these are basically the height of the high water elevation of a given high tide over the 19-year lunar cycle. And so you have some high tides that are somewhat low, you have a bunch of high tides that are kind of in that middle, and then you have some of those really kind of extreme kind of king tide events sort of at the other end of the distribution. And I highlight in red there where we start to observe minor flooding in downtown Portland. If you've ever been there, down by Jay's Oyster, Custom House Wharf, some of those piers up on the Portland waterfront are definitely kind of have a couple of inches of salt water on them without a storm. And so right now, we're seeing this a handful of times a year, 3, 4, 5 times a year. By mid-century, if we realize that 1.5 feet of sea level rise, we're going to shift that whole probability distribution function. So basically what is a more or less kind of normal high tide now is now causing flooding in downtown Portland. And so roughly 1 in 4 days, you're going to have flooding in downtown Portland. 2/3 of Maine's sand dunes are going to be submerged. And almost 40% of Maine's current beach area would be lost. And by the end of the century, if we do realize that 4 feet of sea level rise, the entire probability distribution function has been shifted to the other side of that minor flood threshold line, and we start to basically see daily flooding in downtown Portland. And we start to see 90% of Maine sand dunes being submerged and 75% of the current beach area being lost. So, okay, I'll do something risky here and show you guys your own home, something that I haven't studied a lot, and you guys probably have much better firsthand experience with this, and I'd love to hear about it. But I took a look at the Maine Geological Survey has this sea level rise viewer tool, and you can basically look at different scenarios and see what happens. And this is, to be clear, a little bit of a rudimentary analysis. It's what we call a bathtub model. So basically filling up with that level of water. It doesn't really take into account wave setup or storm surge or other types of impacts that could happen. So this is purely if we were to raise sea level by either 1.5 feet or 4 feet. So this, obviously, you guys recognize Grindle Point. You see the ferry terminal at the bottom left there. This is highest astronomical tide. So you probably see some level of flooding. These marshlands fill in with water. And this is what the commit to manage scenario by 2050 looks like. 1.5 feet of sea level rise, you start to see some inundation of the road leading away from the ferry terminal, and you really start to see that pinch point in that marshland there. And by the end of century, you not only see those pinch points being threatened, but fully inundated. And so if we go up the island to the Narrows, another region that is obviously highly vulnerable to sea level rise. Highest astronomical tide, you have a really short spit where you can still kind of get across. The commit to manage, I was just talking to Peter beforehand, and he was telling me about the riprap that's been installed to really help bolster the resilience of that region, but it's only a matter of time before it can be fully inundated. You can't quite resolve it here, but it is inundated there, and there's another area, another bridge area that is likely to be inundated as well. So point being, you guys are probably really aware of this already, and I'm sure town managers and folks, and I know the island has its own sea level rise committee, which I would love to talk to folks about afterwards, thinking about this stuff. But if you want some more support or some additional information, feel free to reach out to us. And one of the things that is really important to think about in a state like Maine is that there's not only high risk from sea level rise, we're experiencing rates of sea level rise here in the Gulf of Maine that are not only faster than the global average, they're faster than the national average as well. And so we have rates of sea level rise that are pretty high. We also have, a lot of coastal communities that exhibit a significant degree of social vulnerability characterized by access to services, socioeconomic status, and so on. And so the map on the left just shows kind of a color coding based on the percent area lost to sea level rise based on that end of century commit to manage scenario, mapped with the degree of social vulnerability that these places have. And so, unsurprisingly, some of these down east communities that certainly have a lot of exposure and not as much access to services and capacity to respond face quite a bit of risk. On the right is a map that's put out by the Bureau of Resource Information and Land Use Planning in the State Department of Agriculture that basically color codes every township based on the amount of local and regional planning capacity. And you probably can't read the legend, but the blues that are largely concentrated in southern Maine indicate that there is in-house planning staff of a couple of people dedicated to kind of resilience planning. Unsurprisingly, as you get further up the coast, there's less and less capacity within the municipal staff to deal with these issues. And so this is really at the heart of what we at the Gulf of Maine Research Institute are trying to do, is really help build that capacity to respond to the types of risks that these communities are going to face. And it's just one example, which when I first saw this image, I was just struck by the vulnerability that Deer Isle and Stonington face by being connected only through this causeway that is, frankly, at extraordinary risk. And you can see, for those that were around this past December 23rd, there was a remarkable storm that unfortunately sort of coincided with a high tide. From a scientific perspective, it was super helpful to get that data. But from a practical perspective, for people working for public works, departments of transportation, it was an absolute nightmare. And so you can see the plow being used to basically clear rocks and riprap off that causeway. And some kind of stark additional stats there saying for every foot of sea level rise, about 74 acres of upland becomes tidal in this state. And the Maine Climate Council has made an estimation that without adaptation, 300 plus miles of public roads will be damaged by sea level rise and storm surge by mid-century. It's only 25 years away now. So what can we do about it? There's a variety of things we can do, right? Most people think about, when you think about dealing with sea level rise, you want to armor. Your natural instinct is to just put something on the wall in the region to keep the water at bay. That can be riprap, it can be a seawall. Oftentimes, that's the best solution. But a lot of times, more and more what we're seeing is that that actually isn't the best solution. And there are a range of reasons for that, one of which is because when you put something in the water, all you're really doing is deflecting it to your neighbors. And so neighboring communities, oftentimes those that don't have the resources to put a seawall in the first place, are going to be have their risks even more exacerbated. If you go, some of the best places to observe coastal flooding is down in Situate, Mass. There's some really stark examples of coastal flooding impacts there. But structure elevation is obviously a natural one. You see places like this all along the Outer Banks in North Carolina, increasingly being required by local zoning ordinances. And there's a host of what we call nature-based solutions, or green infrastructure oftentimes, whether that's dune restoration, marsh creation, that can sort of not only sort of insulate the impacts from storm surge by helping attenuate wave activity, but those are also really effective carbon sinks, so they have an emissions mitigation benefit as well by drawing carbon dioxide out of the atmosphere. The triple benefit is that it also provides really beneficial habitat, oftentimes for endangered species or juveniles in the coastal zone. So the problem with nature-based solutions oftentimes is that you can't do them everywhere. It needs to be a really particular site that you're able to do it. And finally, the other thing we don't necessarily want to talk about, but this notion of managed retreat, or what we call community-driven relocation. So we start to see this in particular. You're seeing it in a lot of Alaska Native communities. You're seeing it in Isle de Jean Charles down at the Mississippi Delta is one of the classic examples. In South Carolina in the Low Country, this is starting to happen. And the federal government is now literally providing funding for communities to do this. The Makah tribe out on the Olympic Peninsula in Washington State is undergoing this transition right now. And so there's a variety of things that you need to basically be able to do this. First and foremost among them is access to finance. And that may seem obvious, but a lot of times if you go back to that map of planning capacity, you can do all the planning you want, but if you don't have the bandwidth to navigate how to apply to FEMA for a grant, you're not going to be able to get shovels in the ground. And that's a real limitation for a lot of these small municipalities. And so we're currently hiring a climate financing specialist to support municipalities in navigating and accessing finance to do just that. It's also really important to have smart coastal planning, right? It sounds obvious, but it's really difficult when the incentives for the town oftentimes are to develop the coastal zone, right? You can oftentimes get the biggest municipal tax base there, a lot of economic opportunity, but we know that that's going to be the most at-risk infrastructure and probably cost more in the long term to figure out how to deal with it. And the other point we'd like to make sure to highlight here is that oftentimes these issues are really gnarly to deal with in a community setting, and it's really important that the processes by which a community undergoes to think about what's an acceptable solution or suite of solutions for our given place, you need a transparent and inclusive process. And so that means not just holding workshops during the day when a lot of people are working, or only inviting people who have historically attended your events. You really want to try and reach all corners of the community to get people at the table and make sure that whatever is done has as much buy-in as possible. So, okay, what are we doing to address climate change at the Gulf of Maine Research Institute? I mentioned at the top that our mission is to develop and deliver collaborative solutions to global ocean challenges. I'll talk in a second about what those ocean challenges are, but it's important to understand what guides our work in the first place. We are, by definition, locally focused. We really do deep community engagement, not just with the state of Maine, but throughout the Gulf of Maine and the whole seafood supply chain and fishing communities that rely on this region. But of course, what we do here is relevant well beyond the Gulf of Maine. I mentioned obviously at the top that since we are one of the fastest warming places on Earth, we are experiencing changes here that other places are going to see in the decades to come. So the things that we try and fail at or try and succeed at, That's going to be important in cost-saving measures for communities in the years ahead. We take an integrated interdisciplinary approach. I mentioned our basic research team, but that's coupled with a whole bunch of social scientists that are skilled at community engagement. We have learning scientists on staff to understand how people distill and comprehend information. And now we have a body of business development work and the Climate Center that is really bringing a multidisciplinary perspective to address these issues. Importantly, we are not an advocacy organization. We are not an activist organization. We're independent and objective, meaning that we take what the science says, we translate that. We may say, hey, this is a good option, this is a bad option, but we're not going to be in the business of saying you ought to do this or pushing particular measures for the most part. It's really this sort of science-driven approach that really sort of retains our reputation, particularly with the fishing industry, right? Wild harvest fishermen obviously faced enormous stressors, not just from climate change, whether it's the regulatory environment or other things. And, we want to make sure that they are being armed with the best possible information, not just what they're reading on Facebook from their neighbors. It's important that they engage in processes, whether they be offshore wind or right whale regulations or otherwise, with good science. Everybody needs to be armed with the best available information, and we try to make it possible for that to happen. And as I mentioned at the top, we take a really inclusive and collaborative approach. We involve stakeholders in the definition of our research questions. We co-develop the solutions, so what we ultimately come up with is going to be applicable and feasible in the real world. So what are those global ocean challenges? The first is seafood sustainability. We like to promote locally harvested seafood. Not only does it have a lower carbon footprint generally, but we have really high quality seafood in this region. And that really depends on having healthy ocean ecosystems as well. And so you can't have a healthy ocean ecosystem without understanding climate change and the impacts that are happening. And the fourth one, of course, is ensuring that this region has a bustling and thriving marine economy in light of climate change and all these other stressors. And I kind of highlighted how we do this across our kind of 5 branches. I mentioned the science, education, and community. That Gulf of Maine Ventures piece is our new business development arm, where we're helping to not only build new businesses based on GMRI know-how. What have we learned over time that we can spin off into new companies? And we've done it both with an electronic monitoring company as well as a premium seafood company called TrueFin. And of course, then there's the climate change, the Climate Center, excuse me. And that's what I lead. And what we're in the business of doing is delivering climate services to coastal and marine stakeholders. And a lot of times people are like, Dave, what's climate services? That sounds like federal bureaucratic speak. And it is. But you guys are probably familiar with financial services or health services or other types of services. That's really what climate services are as well. It's taking scientific information, raw data, translating that into a useful form that people can make decisions with, whether they're a small business owner, a coastal homeowner, or a municipal planner. And we do it through a really stakeholder-centered science engagement solutions framework. So we do the science, we do the engagement, and ultimately want to co-develop those solutions with people. And this is just a range of the different types of capacities we have across GMRI to sort of address these issues. The ones in white are capacities we have on staff now. The yellow ones are where we're going to be growing in the next couple of years. And so we've historically been really involved in characterizing and understanding the impacts of climate change to the marine environment and to fishing communities. But increasingly, we're going to get into the business of emissions mitigation, right? At the end of the day, even though the state of Maine contributes only about 0.2% of greenhouse gas emissions to the national inventory, it's important that we all take action. Because if we don't, then our neighbors don't. If the U.S. doesn't, then China doesn't, and you can see how this cascades. So it really is an all-hands-on-deck approach. And I mentioned kind of the type of stakeholders that we engage with. It ranges from students, teachers, informal educators, be they librarians, 4-H leaders, scout leaders, folks involved in the seafood supply chain, whether they're in the management system or in the dealer, processor, retailer arena. And increasingly, we're working to engage municipal officials and the public not just at the municipal level, but at the regional planning organization level and at the state government level as well. And when it comes to the solution side, I mentioned kind of the climate financing capacity, but it's going to be increasingly important to think about land use planning and coastal zoning, thinking about how do ordinances that have been in place for a long time need to evolve to accommodate the changes that we're starting to see in this region. And I'm going to end with just a couple of slides that illustrate some of the types of work that we do within the Climate Center to give you a flavor. This is a satellite view of Union Wharf on the Portland Harbor. GMRI purchased Union Wharf about 2 years ago now because the Poole family, who had owned it for about 150 years, wanted to get out of the wharf owning business. And the dozen or so wild harvest fishermen that docked their boats there were deeply concerned that it was going to turn into 2 piers over, which is basically high-end condos by developers. And they were really felt this palpable threat of development and loss of their livelihoods as a result. So we purchased it after doing a pretty exhaustive search to see if anybody else would please purchase it and protect and preserve the working waterfront, because that's really inherent in our mission. And so by doing so, we now have an actual laboratory where we can start to characterize sea level rise and coastal flooding at a hyper-local scale. And so this is what we've done. Basically, this looks at more or less the 10% storm in 2030, so a very reasonable chance of occurrence, and what the water depth would be on the wharf. And you can see the dark blue, kind of in the middle of the wharf there, is a water depth of more than 90 centimeters. So you're thinking almost 3 feet or so, right? And that's really because the wharf is kind of concave shaped. There's a storm drain right there, and the water comes right up through that storm drain. And you can also see a highly vulnerable part in the corner there where the water starts to seep in. And so the problem with this, and what we're starting to do, is to characterize all the utilities on that wharf. Because as soon as a furnace goes under salt water or is exposed for a certain amount of time, the heat goes off, the pipes freeze, and you have a really expensive problem to solve. And so, as a landlord, you don't want that. As a tenant and a business owner, you certainly don't want that disruption to service. And so what we're trying to do is to characterize which utilities are most at risk. How high are, it's very, very straight, this isn't rocket science. How high is that furnace off the ground? How high are the heat pumps? How high are those electrical panels? And how much would it cost to either replace them or to elevate them or to otherwise protect them from exposure to salt water? We also, as I mentioned, do a lot of community engagement. We do something called community resilience training, where we have a 3-part sort of series where we basically do a sea level rise awareness training, like a sea level rise 101 for community members to understand, raise their capacity to understand what the risks are. We walk them through something called Planning Forward, which is a scenario-based planning exercise that really helps them explore what are the different options that we can do in our community. And I'll show you some, just some pictures of what that looks like in another slide. Once we walk through that scenario-based planning exercise, we have elicited kind of the values of the community. We have walked through different options and started to get a better understanding of what palatable response options are going to be. And that enables us to start to convene a resource workshop where we bring engineering firms and financiers and all sorts of people together to basically present how they can address climate change in their community and do some matchmaking. And ultimately that informs a resilience planning exercise that can inform, say, town comprehensive plans. So just a couple quick, and then finally, a really important one is our coastal flooding community science work. This is really where we get people out into their environment, taking observations. Just take your phone, take a photo, upload it to our website, and what that does, and you basically tell where you are, when that photo was taken, and what sort of weather conditions were present. And that really helps not only inform the models that we develop, it helps the National Weather Service issue better flood alerts. There's this remarkable stat where basically in southern Maine, I think over the past decade or so, the Weather Service has issued something like 60 flood alerts in southern Maine. They've issued about, I think, something on the order of 15 in mid-coast, and they've issued 3 flood alerts, coastal flood alerts, in down east Maine. And it's not because the flood risk is any different in those places necessarily. It's because the lack of data inhibits them from actually making informed projections. And so by getting people out there, making these observations, we can have better early warning systems. And so just to kind of show a couple of photos of when we went out to Vinyl Haven and North Haven a couple of months ago of what this planning forward experience looks like. It starts really with getting people to talk about what do they value about their community. Because when you start to elicit those values, you start to basically lay out what priorities might be. What do we want to protect and preserve? Is it the hospital? Is it the downtown park? Is it the electrical substation? Is it everything? What are the trade-offs associated with protecting everything? And that's where you get into the actual exercise, where you run through these different scenarios at different time steps throughout the century. So you have a little bit of sea level rise in present day, more by mid-century, and quite a bit by the end of the century. And what are the impacts of that going to be? What are the other stressors going on in the community, whether that be in-migration from New Yorkers moving during COVID, or is it something else that is changing the characteristics of that town, introducing new stressors or opportunities? And ultimately, what are the strategies that we can pursue? And those strategies could involve anything from standing up a climate action task force, or issuing a municipal bond, or developing a climate impact awareness campaign. And there are costs associated with those, and so you have to manage a budget through this process. And it's really just getting people into that kind of municipal planning mode to understand what the real trade-offs are. And I just like this quote from the Region 1 Resilience Coordinator. When we did this out on Vinyl Haven and North Haven, it was very intentional to do this both with high schoolers and with retirees on the islands. And it's really fascinating to get that intergenerational dynamic going and understanding sort of what are the concerns and frankly experiences that some of the older people in the community have really witnessed over the years, and what are the young people most concerned about, you know, and where can we learn from one another, and where can we frankly move forward. And so with that, I'll just leave you with what we really hope to achieve with this work. You know, our whole goal with not just GMRI, not just with the Climate Center, but with the Gulf of Maine Research Institute as a whole, is to make sure that the coastal communities that really define this region in so many ways can continue to thrive for generations to come in a warmer world. And the characteristics that you see up here on the screen are what we believe really define what we value about living in the coastal zone here. So with that, I want to thank you. You have my contact information and our website, and I'd be happy to take any questions you might have. Yeah, question right here in the orange hat.
How successful have you been dealing with so-called climate deniers?
Yeah, so for those that didn't hear, how successful have we been in dealing with climate deniers? Well, I'll tell you, before I came to Maine, I worked in D.C. I had the pleasure of working not just in the Obama White House, but also the Trump White House on climate issues. You could imagine that there were stark differences in the priority that those two administrations placed on climate change, and it was a really valuable experience to work in both places, because you learn to talk about issues that you don't necessarily agree with the people that you're talking with, right? You meet people where they are. And there's something that I really was pleasantly surprised about in working with Maine communities. I didn't quite know what to expect, particularly in some of these smaller, more rural places that typically tend to, you know, potentially embody sort of denialist behavior when it comes to climate change. And at the end of the day, people are pragmatic around here, you know? They say, look, I see that the dock is flooding, you know? And maybe I can't engage them in, hey, you should think about putting a heat pump in your house, right? But I can talk to them about, okay, what do you want to preserve about, you know, the town dock or the working waterfront down here? And so you just got to figure out what it is they value, what it is they care about, meet them where they are, and take them as far along as you can in that climate action. There's been, I will say that in every community we've gone to, I've been really surprised that there's always at least one vocal champion of climate action. That may be a lonely voice in that town, but there's always someone who will have that hook. And as long as you've got that kind of person that you can kind of lean into and provide that kind of local context, you can kind of have some, make some traction. So again, I think it's really about meeting them where they are, respecting their perspective, even if you don't agree with it, and, you know, addressing the very pragmatic nature of the risks that they're facing. Yeah, Victoria.
I understand about the Labrador current and the Gulf Stream, but is the Gulf of Maine shallower than most other places?
It is, yes. Yeah, no, it's...
Greater than that, because you can't fix that.
We can't, it's true, right. And so that is a contributing factor, right? I mean, you know, the Gulf, it's, you know, from a human perspective, maybe it's deep, it's about 100 meters or so deep, and, but, you know, once you get off of George's Bank, obviously it drops off precipitously. You know, you're thinking kilometers deep, right? And so, yeah, and that makes it therefore, you know, much more susceptible to surface warming, right, from the sun. And expansion, right? Yeah, exactly. So you're right. I mean, the bathymetry, you know, with George's Bank in particular, kind of cutting it off a little bit, but also just the shape of the Gulf by definition, sort of, like I said, kind of constrains it a bit. So
wouldn't that make it important even more that we should be working on it when we have the disadvantage of having a shallower surface?
absolutely right. Victoria, we're going to hire you, and you're going to come out on the road with us. Thank you. Good. I didn't even seed that one. That's a great point. Yeah.
Here's other risk factors to the Gulf of Maine,
Yeah.
specifically pollution.
Yeah.
The real risks there that we should be addressing along with climate.
Yeah, it's a great question. And one of the best places to look for that information, well, at least around Portland, is the Casco Bay Estuary Partnership. They do fantastic work to really characterize other stressors into that bay environment. I suspect Penn Bay has a similar entity. I just have to plead a degree of ignorance. But yeah, I think, you know, obviously fertilizer runoff tends to be one of the most damaging in a lot of ways. And that, you know, that nutrient runoff, that the phosphates, the nitrogen, those types of pollutants really do pose risks into the coastal zone. As I mentioned, kind of thinking about that, the triggering of harmful algal blooms. You know, I grew up in upstate New York in Rochester, and, you know, we salted our roads in wintertime, right? I live in South Portland now, and springtime is an absolute mess because my road looks like a beach because they put down so much sand. But, you know, the plus side is that, you know, you see signs out that say low salt area. Those tend to be places that have really ecologically sensitive marshes or other types of regions. So certainly salt application is one of them. You know, residential fertilizer is not to be underestimated as well. So the other thing that's, you know, potentially going to be an issue in the years ahead, I suspect many of you have septic systems, right? As sea level rise happens, you're going to have saltwater intrusion into kind of through the groundwater, through the soil and the rock, depending on what type of rock it is, and you could start having other types of pollution as well, kind of a reversion back to the early 20th century, if you will. Yeah, in the red shirt.
On the same slide that Bill was mentioning, U.S. stratification, I wasn't familiar with that. Can you comment on that?
Yeah, no, it's great. I will say that image, it's hard to show stratification from a top-down view because really it's kind of different levels of the ocean as opposed to sort of, you know, kind of a XY. It's more of a Z coordinate, if you will. But really what happens oftentimes is when you have warm water at the surface, warm water is less dense than cold water, so it's going to rise, right? Just like warm air is warmer than cold air. And what that can do is it can provide a bit of a cap on that surface. So you inhibit mixing of the ocean, right? And when you inhibit mixing, you inhibit upwelling and nutrient exchange and exchange with the atmosphere. And that sort of air-sea exchange and that sort of surface water, bottom water exchange of nutrients is critically important for ecosystem health. And so what can happen a lot of times with stratification because of warmer waters is you have deoxygenation that follows. And so you basically create anoxic conditions, and you guys are probably familiar with what happens in anoxic conditions. A lot of things can't survive. So that's, hopefully that explained it a little bit. Yeah. Yeah, Gail. Sure.
You're doing a lot. What is your budget? And how is it funded?
Yeah. What is our budget? So the question was we're doing a lot. What is your budget and how is it funded? Our budget as an organization is about $15 to $20 million per year, give or take. And within the Climate Center, it's give or take every given year, probably a few $1 million. And that's growing over time, in part because we've not only been successful at writing grants to the federal and state government, but we have a really wonderful development department. We do rely heavily on individual philanthropy as well as foundation support, family foundation throughout the state and large national foundations as well. So, to give you a split of the pie, Maggie would probably be better at telling you this, but I think we're roughly about half of our funding comes from federal and state proposals that we write, maybe about 25% or so, 30% comes from individual philanthropy, from foundations, about 20%, 15 to 20% from individual philanthropy, and then a little bit of a residual from corporate sponsorships and support as well.
Follow-up question. Do you expect to be able to get funds from the Inflation Reduction Act?
I sure as heck hope so. We're in the middle of writing proposals now for it. There's been a ton of money coming out as a result of that, particularly through NOAA. There's a lot of resources right now, and it's across all federal agencies. And in one sense, it's fantastic, right? We have a lot of funding available to us now to start to address these challenges. Part of the challenge, of course, is that it's a one-time infusion, right? We have no guarantee that this is going to be, we could write a proposal for 4 or 5 years, but we don't know if that funding is going to be sustained. And in all likelihood, it probably won't if past is prelude in terms of congressional activity. So it's really important, frankly, that we can not only create some real momentum with the funding that we do have at our hands now, but demonstrate impact so that we can go out to communities and sort of say, hey, it would be great if you could, if we can leverage your investment to advance what we've done historically and make us that much more competitive going forward. Yeah, it's a great question. Thanks. In the back here.
Have you done any research on the impact of floating windmill kind of things and how they impact the ecology?
Yeah, it's a great question. For those that didn't hear, the question was around the impact of the proposed floating offshore wind technology in the Gulf of Maine, and in particular its impact on the ecology of the Gulf of Maine. Where to start? So you guys are all familiar. I don't want to be too patronizing with this, but I think it's important to kind of calibrate our understanding. Most offshore wind that exists not only in the U.S. but around the world is what we call fixed bottom wind. So it's basically like a monopile or some other type of sort of fixed bottom infrastructure. Because of the depths of the Gulf of Maine, that isn't really economically or technologically viable, so we have to do what's called floating structures. And basically, generally, the most common way to do that is to have like a large concrete kind of hull structure that has really large sort of chain tethers, basically, that are anchored to the bottom. Those chain tethers aren't like other types of lines in the water. You're not going to get whales tangled in something that is that rigid. But there is a real question about, just the disruption of these, the sort of site characterization as well as the actual construction. What does that mean for the environment? We are involved. The state has done a fair bit to stand up an effort. There's an offshore wind research and development consortium, which we are a part of. We actually have a couple of research vessels, or actually one research vessel that is capable of going 20 miles offshore. So you may be aware that there's a site that's been identified for the research array. So we are part of a team that is doing baseline ecological monitoring. So, best practice in this type of incident is you characterize the environment before something happens, you characterize it while it's happening, and then you characterize it after it's been installed, and you sort of see the before, during, and after piece. It's an open question, to be perfectly frank. We don't quite know because we haven't really done this before, certainly not in this region. And there's a lot of research out there, much of which is inconclusive. There are things that suggest that anytime you place something in the marine environment, it naturally attracts things that grow on it. When things grow on it, that can attract other things to eat those things that grow. So you could actually, stimulate some new ecosystem activity, but it's, I think, far too early to determine what the net impact would be.
Can we take one more question and then leave
All right, one more question, and I'll stick around a little bit after. I'm sorry, I think I saw your hand first, yeah.
I was just wondering about the Woodsville Oceanographic Institute.
Yes.
Can you do anything with them, or could you, with their staff?
Absolutely, yeah. So the Woods Hole Oceanographic Institute is kind of the 700-pound gorilla in the region. They are a behemoth, and they are phenomenal. We are part of a NOAA cooperative institute with them called SINAR. It's the Cooperative Institute for the North Atlantic region. So it's us, I think it's the University of Maine, what we call WHOI affectionately, the Woods Hole Oceanographic Institute. I think the University of Maryland, Eastern Shore. There's a few other universities in part of it. And basically what it is it's a cooperative institute under NOAA that we've basically put forward a proposal that says these are the priority issues we're going to address over the next 5 years. And NOAA basically allocates a certain amount of funding that we sort of internally compete for. And so that's certainly a big part of what we do with them. They are really, WHOI is, again, a top-tier institution globally, not just regionally. But they are really expert at a lot of the UAV work, the underwater autonomous vehicle, so they're really skilled at that. I'll say the kind of West Coast complement, if you guys are interested in sort of Googling some of these institutions and learning more, is the Scripps Institute of Oceanographic Studies at UCSD. So, but of course, I'm a little bit biased. I think the Gulf of Maine Research Institute is maybe not the 700-pound gorilla, but we're about 200 to 300 pounds right now, and we're growing. So, great. Thank you all very much.
So, David, I want to thank you on behalf of the entire audience. You can tell from the level of energy and questions that there's a great deal of interest in this, and we're very fortunate to have you here. In fact, I think Maine is very fortunate that David left the federal government sphere and elected to settle in Portland because you were drawn to it, as I understand it. So thank you again. I'd like to just say a few words about next week's program, and it actually ties in very nicely with some of the things David had to say about aquaculture and the healthy ecosystem for growing mussels and oysters and kelp. We're going to have a program featuring our local growers, a panel of growers, vegetable, kelp, oysters, mussels, and John Rexwaller will be our moderator of that panel. So I hope you all will plan to come to that next week, same time, 5:30. And with that, I will adjourn, but David has kindly offered to stay around if some of you want to swarm around him and ask a few more questions. Please feel free to do so. Thank you.